Today I'm going to respond to a comment made by a viewer who goes by the name of ErvBlog. And his comment is about the video that's a question about the video on conventional current and electron flow. And his comment is, yes, but the movement of the lack of something, electrons or holes, is very confusing to me. I was taught that there is no such thing as positive voltage, just relatively less negative voltage. But it works either way. Good explanation. Well, thank you for the compliment, and I want to just respond to what you had to say, and I'm going to break your question down into its parts, and so we can respond to each one. So the movement of lack of something, or electrons or holes, is very confusing to me. Well, let's take a look at an instance where it might not be so confusing, and let's do that by playing a game of golf. So you are playing a game, you get to the green, and there's a hole in the green, and that hole attracts golf balls. We know that because that's where the golf balls eventually end up. Now, my friends who play golf may not think that's so funny, but the fact is that's where they go. So we'll consider that hole an attractive force that attracts golf balls, because that's what it appears to do. So you come to the green, you putt out, and you move on. But the next day you come to play another round of golf, and as they usually do, they will move the hole from one place to another, sometimes on a daily basis. This not only makes the game more interesting, but it's good for the health of the grass. You don't want to have everything happening all in one place, people all walking in the same place, so they move the hole around the green here and there. So you come back the next day and you say, oh, they moved the hole. Did they move the hole? No, they didn't move the hole. A groundskeeper came in, cut a plug of grass and dirt from here, and moved it to where the other hole was. What moved was the grass and the dirt. So this is sort of like, watching a sunrise. Now, we know that the sun is not really rising. We know it's really the Earth rotating the opposite direction. But do you go out and say, oh, what a beautiful Earth rotation we're having today? No, you call it what it looks like. You call it a sunrise because it appears to you that the sun is rising. Here, it appeared that the hole moved. Now let's take a situation. Let's say they moved the hole, started here, and the next day they moved it to here, and the next day they moved it to here, and then to here, and here, and here, and here, and each day they move it just a little bit to the right. And you come and you see what looks everything to you like that hole is moving to the right. But you know what's really happening is they take a plug from here and put it there, then another plug from here to put it there, then another one from here to put it there, and there, and there, and that's what they do over and over again. So it's not really the hole moving, but it's the plugs of dirt. Different plug of dirt each time that's moving, but it looks like the hole is moving. So that's really not confusing, is it? It's a very similar situation to what happens with electricity. Let's take a look at let's say we have a field of electrons. I'll just draw it as a bunch of dots, try to make them fairly evenly spaced. And let's say we do something, maybe a wave of energy goes through, or some way we cause some of those electrons to bunch up in one area. So let's say we get some electrons from here to bunch up over there. So now we have a bunch of electrons, and very plainly a place where there's no electrons, a hole, if you will. And the same thing happens with semiconductors. We don't see these things happen, but we do model it. And if you could actually look down at a microscopic level and actually see the movement of electrons in semiconductors, you would see the same kind of thing we're talking about. Here we have an absence of electrons, which is going to attract electrons in. And here's an overabundance of electrons, which will repel electrons away. And so there's a real attractive force there. It's an attractive force of nothing, but there it is. So there's a way to look at the movement of holes, or the movement of nothing, that moves the opposite way of electrons. And if we go back to the golf course, where it's very, very clear on the green that when the hole moves from place to place, we know it's really the grass and dirt moving, but it sure looks like the hole is moving the opposite direction. And this is very real. If we go down to the molecular level, we find this happening in the flow of current, where we have electrons going one way and we have these holes going the opposite direction, and they really are there. And this concept where when electrons are moving one way and holes are moving the opposite direction is very important to the existence of magnetism. What we have there is, from our frame of reference, we see electrons going one way and we see the positive charges or the holes going the opposite direction. If we could look with a microscope that could see electrons and positive charges, that's what we would see. We would literally see what looks like positive charges moving the opposite direction. And because of special relativity, when they are moving from our frame of reference, they are length contracted, so they're closer together. So if the electrons and holes are not moving, they're so close together, but when they start moving, they become more concentrated. But the electrons are going one way, the positive charges are going the other direction at the same speed, and so we see them both length contracted or concentrated by the same amount. So there's no imbalance of charge. But let's say we hop a ride on one of those electrons. Now we are moving with the electron and we feel like we're not moving. We think we see the positive charges going the opposite direction at twice the speed. And because they're moving relative to us, they're more concentrated now, and so we see a stronger positive charge than negative charge, and there's an attraction there. Riding with the electron, we see it's plainly an electrical attraction, but we hop off, and now we see the electrons and the holes moving opposite directions at the same speed. They have the same concentration. There's no longer an imbalance. We don't see that electric charge, and so we see an attraction, but no electric charge. We call it magnetism. You can see my video on electricity and magnetism that I have linked in the description below and up here. And that explains why electricity and magnetism are the same thing. And there's some other videos that I link in there that explain the same phenomenon. So back to the concept of when electrons move one way, holes move the opposite direction, and you have a hard time wrapping your mind around the fact that nothing is moving. Well, in the case of the golf hole, nothing is moving in this direction. Everything's actually moving the opposite direction. But to you, it sure looks like the hole is moving in the opposite direction. So it's very real. The next thing you say is, I was taught that there is no such thing as a positive voltage, just relatively less negative voltage. And I have no trouble with that philosophy. That's a valid philosophy to look at it. But as I showed in my other video, we can imagine that electricity is something that's positively charged, moving in the opposite direction of what's really happening. So it's an imaginary thing. It's just something easy for us to wrap our minds around. Just a quick reminder, here's a simple circuit, a battery, a resistor. Let's make it 10 volts, 10 ohms. I seem to pick those numbers quite often. And we have a current of 1 amp going through there. And which way is it going? Well, if you follow the electrons, the current is going this way. Or we can follow an imaginary electrical fluid that goes the opposite direction. And the circuit works the same way either way. So it's just imaginary, but because it's moving from a higher voltage to a lower voltage, or higher pressure to lower pressure. And here's another example of just what you said. There's no such thing as positive charge, just more and more negative charge. Well, why is this positive? Remember that positive and negative are not opposites, just differences in charge. So a negative voltage is just a voltage that's lower than some other voltage that we call zero. So higher voltage, lower voltage. Higher pressure, lower pressure. That's the way I look at it. Higher pressure, lower pressure. You're just saying, oh, I was taught that it's really higher pressure, lower pressure. Works either way, but most people wrap their minds around better if we say the positive is higher and the negative is lower. It's just natural, and so it seems like everybody's going this direction. But if it works for you to go the opposite direction, more power to you. So yes, that's a good philosophy. There's no such thing as a positive voltage, it's just less negative. So most people have transitioned to positive is higher voltage, negative is lower voltage, and the current goes from the higher voltage to the lower voltage, or the higher pressure to the lower pressure. So that's just my comments on what you had to say. I think what you said is valid. I hope that you can see that, yeah, just because it's nothing moving, it sure looks like something, just like the golf hole. It may be nothing, but it sure looks like something, and it works exactly the same way. And once again, if it didn't work that way, magnetism would not be what it is. If you found this video useful and informative, please give me a thumbs up down below. It really helps the channel. And subscribe, because that not only informs you when I put new videos up, but it really helps the channel also. And a big thank you to my patrons at Patreon. I could not make these videos without your support. If you want to help me put these videos online and keep real vocational education free at vocademy.net, you can go to patreon.com/join/vocademy and pledge your support. And again, a big thank you to my patrons who make this possible, and a big thank you to everyone for watching.